Hello and welcome back to another video. In this problem, we're asked to graph the given functions on a common screen, and we're asked how are these graphs related. So we have y equals e to the x, e to the negative x, a to the x, and a to the negative x. And so we know, based off of what we've done in this section, that y equals e to the x and y equals a to the x are going to look very similar, right? They're going to have this general shape where they're close to 0 for the negative numbers, and they hit the point 0, 1, and then they go off to infinity. And we know that e to the negative x and a to the negative x are going to do the opposite. They're going to start out at infinity, and they're going to approach 0. Graphing these on a common screen, what we're going to do is we're going to do this on a graphing calculator, and we're going to look at the small details, these small differences between all of these graphs. So we take here, in Desmos, we have these functions graphed. And what we're going to do is say, okay, what is the difference between these two graphs? Well, we have e to the x in red here, and it is increasing slower than a to the x. Over here, the e to the negative x is decreasing slower than a to the negative x in purple. So what we can see is that the higher the base, the greater the rate of change, right? These a to the x, purple and green, with base 8, they are decreasing a lot quicker. Again, we can see that they're all at 0.01, because any value to the x power for x is equal to 0 is equal to 1. We can see here that they all behave in the same way and that they all go off to a positive infinity in one direction and 0 in the other. Over here we have e to the negative x and 8 to the negative x, starting off at negative infinity as you go towards negative infinity for x, and they approach 0. And as they approach 0, the 8 to the negative x decreases a lot quicker. Again, greater rate of change. And on the other side, as we're approaching 0, the 8 to the x also decreases a lot slower than the e to the x. So I hope this was helpful in actually visualizing what these functions look like better than a hand-drawn graph, right? We can look at the specific changes in the rate of change, right, called the slope basically of these functions, if you change the base from, let's say, e to 8. And what happens if you go from 8 to the x to 8 to the negative x. All these changes are a lot more visible when you're graphing it in a graphing calculator, so I hope this was helpful.